Hello there, folks. Here's a quick video just showing a customer sent me an application that won't compile in Crimson Control, and so I thought I'd take a second to look at this and see if I can figure out what seems to be the problem here. So this customer is using the Crimson Control method, which is our ladder logic new thing we have here. They've got a simple ladder logic run written here, some digital inputs here going through and turns on an output. And they've got a greater than function block here. If AI1 is greater than AI2, it's supposed to turn on output number 2. So here's the program. It's not compiled at this time. So if I take my cursor and hit the syntax check here, boom, you can see that the program comes up with errors. So let's look at this. You got F4 to navigate through the errors or F8 to show them. So right away, if I stop there, if you notice, it highlighted this guy. I started this, I put it here again, I'll just show you once again. And if I click this, it instantly jumps to this thing here, which is kind of strange. Okay, that's weird. If I push the F8 button, brings up the syntax errors, and then look here. It says, hey, the assigned variable and expression must have the same type. So, so that's interesting. Well, if I look at this function here, if this is greater than this one here, it's supposed to turn on the output number 2. So if I go over here to the left and click on this tag that's in the PLC program here, I can see output number 2, but it's declared as a double integer. I believe, team, that it should be a Boolean, flag type or Boolean. So if I hit the pull down here and slide to the top and declare this as a Boolean tag right here, I've declared that as a Boolean tag. Now if I go back to my program here and once again go ahead and let me put my cursor right here. I'm going to go ahead and retranslate or compile. Let's see. No errors there, so that works. That fixed that problem. Now you always want to build the project to see if the project is correct. So I'll do this. Project is compiled without errors. So now the project is complete, or at least the ladder logic part is true. While I'm in here, I always like to check something. If I go to the programs here, and I can see here that they are executing this on each cycle, so that's a good sign. So that means it's going to actually run in the program. Over here, there's nothing here. Yep, and it's going to also execute here, so that's a good sign. So the next thing that I would look at in this is, well, these are the variables that are run in the ladder logic, but if I click on data tags on the left, we also have the variables here in the HMI part of the application. And I can tell based on the display page that I think the customer wants this to actually interact here. Do we have any modules? Let me look here. We have a discrete I/O card on here, and we also have an analog input card on here, along with we have our Crimson Control module. And now you see here, there's no Crimson Control, but if I go to Communications, and the Crimson Control module has to be inserted here. So there's going to be another problem here. This customer doesn't have the Crimson Control, and this is an HMI, so it needs to have that. So what this person will need to do is either slot 3 or 4 or 5. I'll go with slot 5 here, and I'll hit the pick button, and I'm going to put in the Crimson Control module. That's the software key needed, so they'll need to add that here into slot number 5 on the back of that plane. Okay, so get back to the ladder part. If I go back here, let me look at these variables. This is in the ladder logic part, so if I click on DI1 here, I can see that it's internal to the ladder logic. It's not actually linked to the tags that are in the HMI section. So if I go over here to the right side and I can see data tags here, these are the data tags that are coming from the HMI. You can see that these are green because they're linked to the actual I/O modules. This one right here, I believe they're linked to this. Let me check. Hold on. Let me go to data tags over here. Yeah, and I can see they're linked to the module, and this guy is module 2. Perfect. All right, so let me go back to here. What I want to do, though, is I want to link these in the ladder logic program to those external tags. So I'm going to drag, watch this trick. I'm going to drag the tags over here on the right side. These are the HMI tags. I'm going to drag this guy right here. Boom, right there. That's going to link that tag to the real-world inputs. And I might as well go ahead and fix all these while I'm here. So I'll take DI2 here to that guy. I'll click on DI3, and I'll drag this guy right here like so. And I'll do the same for DI4. This guy right here, link it right there. And then while I'm in here, output 1, I believe the customer is trying to fire this one right here, this DO1. I think that's what he's trying to do. So I'll drag that guy there, and I'll click on the AI1. I'll link that to this AI here, and I'll go to AI2, and I'll link that to this guy right here. I do wonder if this should actually be just an integer. I don't know if that actually matters. I'll try it as an integer, and I'll send that back and see, but I don't believe it's a double integer. I think they're just an INT 16-bit word. And then I'll click on the output 2, and I'll link that to this digit output 2 here. And that should do it. If I go back to the display page, everything looks good. I'll just recompile the whole database by going to File, pull down Utilities, recompile. I don't see any errors. I'll go File, Utilities. I'll just recompile ComBlocks. And that should fix it. It should now run correctly. Well, one thing I will look at too is in here, I'm going to make these boxes a little bigger because they're going to get a value from that card. So I'll make that one bigger. I'll right click, same size as this guy. Okay, and then let's look at something else here. If I go back to the IO modules here, I'm going to look. I just want to point out that this customer is expecting to get a 0 to 10 volt for their analog input. And one thing that Crimson will do, we will actually feed a 0 to 10,000 value over that range. So when they go to look at this on the screen, this is going to be basically 0 to 10,000. If we want to change that to look at like 0 to 10 volts, we could go here, click on this guy. I'll click on my AI1. I'm not a fan of this default integer, so I always change it to an unsigned integer. And then down here, I'll say scale to integer. And I know it's going to come in as a 0 to 10,000. That's the raw form of this guy. And if I make a display, I could actually make this show up as a, let's do a 0 to 1,000 here, like that. And then if I go to the Format tab, the Format tab right here where it says General, hit the pick, declare it as numeric, and I can make this show up as a 2 to a 2 here. And then if I go back to Data tab, down here in Simulate, if I put in the number 1, 2, 3, 4, just so you guys can see, go back to Display Pages. Once I click this page, it shows that number there. So I believe that's going to show them a 0 to 10 volt, and I'm going to be lazy, and I'll copy the same thing to this guy. So I'll make this one be unsigned integer, and then if I right-click here, I can say copy from, and I want to copy the scaling, which is this section right here. Copy scaling, and I'll click on this guy right here. Boom, boom. I should have copied all that. It sure did. And then on the Format tab, I'm going to copy the formatting from here. So I'll go right-click, copy from the Format tab to from this guy. That got all that stuff perfect. And if I go back to here, I did 1, 2, 3, 4 on the other one. So I'll do 5, 6, 7, 8 this time. And if I go over here, boom, shows it. And that should do it and should run the logic. So is there a way to test this? Let me look at something here. If I go here, I got this here. I'm not live, but I don't know. Can I test this live? Let me look at something. This is no good. Oh, wait a minute. Program cannot be checked because of user time. Oh, what's this mean? Okay, hold on here. Program cannot be checked because of user-defined function block errors. So maybe I didn't like that. Maybe these things have to be double int. Let me look here. Let's try it again here. Okay, so apparently this function block that I'm not a PLC guru expects to see double integers. No big deal. We're just going to be putting integer in, so that's okay. So it should be fine. That should work. I'm not a PLC guru, but I bet if I look at the this control, it probably declares these has to be double ints. No big deal. That should work. So I'm going to go ahead and save this and send it off to the customer. Oh, I was going to try this. Let me see if I can I simulate this offline, simulate offline. So I'm going to go here. Let's see what it does. Hit start. And if we look right now, I can see the logic here. you can't really click on the display page and make a change here. That's not possible here. But over here in the program, this guy right here, am I still online? I don't think I'm online. Let me go try it again. Simulate offline. Say, yep. So if you click on these things, you can make them true. And you can see that I'm going through this complete AND statement here. And it should be running. So true, true, true. Okay, that's false. Let me turn them back off. Okay, that makes that statement true. I was reading that wrong. Sorry about that. And then if I go here, let's say that I change this analog input here to be 4, 5, 6, 7, just something thrown out there. Notice when I change this one to something less, the output stays false, but I've changed this number to, say, 5, 6, 7, 8. Now it's greater, and you can see that goes true. So I just tested the logic offline here, and it should be fine. So I'm going to go ahead and stop my running here. Don't need to save the program I already have. So I'll send this off to the customer, and we'll see what happens. So hey, thanks a lot. Have a great day, folks. See you later.